do you think that I want you to put arrows on the end of this line? It keeps going. How many points are on that line? This one, 5, but how many points are on that whole line? An infinite amount of points. Actually, how many points are between here and here? An infinite amount. Do you know why? Right. Right, it's, well, the line's continuous, that's exactly right. And it's not like just whole numbers are inputs, right? You could say -1.5, or -1.8, or -1.8888936, and get a different number every time. Okay, all right, is everybody feeling like we get it?
Yeah.
Great, now we're gonna do something a little harder. Example 3. This one is the equation y equals 3. All right, so we're just doing y equals 3. Lincoln, I just heard you whispering, and I feel like you're whispering about this. Do you have an idea what this is going to look like?
Well, I'm not sure exactly. I asked Lydia if I should multiply -2 times 3 or if I should just subtract it right away.
That's a good question. Okay, so -2, -1, 0, 1, 2. Let's look at this equation right here. Y equals 3. Is there an x in this? No. So this is the equation where y is always 3. So what if x is -2?
And it's -2 and then 3 at the bottom.
Okay, so you're saying that basically there's no work here at all, right? We don't even have to plug them in? Because what is y always going to be? 3. And so what Cameron is saying is that the point will be -2, 3. The next point's -1, 3. 0, 3, 1, 3. Callie? Was it you?
Yeah. This was, I know what you're talking about.
When we were doing functions, what was your function that I gave you? The Callie of x was 6. Do you guys remember that?
Yeah.
Callie of x was 6, and so no matter what number I said, Callie said 6. You guys understanding? Okay, so when I graph this one, which we're going to do real fast. The points that we are graphing are -2, 3, -1, 3, 0, 3, 1, 3, and 2, 3, which is just a horizontal line. It's the line where y is always 3. In fact, I'm going to write myself a note here right now where I'm going to say if you ever have an equation that looks like y equals a number, that's a horizontal line. And in fact, if you realize it, I give you permission to not even make a table, to go straight for the graph. Does that make sense to you guys? What do you think it would be if it was x equals a number instead? A vertical line, yeah, I'm going to write that one down too. So I'm going to write, if it's x equals a number, that would be a vertical line. So if it was x equals 3, it would be a line going through 3 that goes straight up through 3. Okay, we're only going to do one more, and again, it's a little bit tougher. Example 4. What if I had said instead this? 8 minus y equals x. Can somebody tell me why this problem is different than what we've been doing?
It's not y, because it equals x instead of
Right, equals x instead of y, and that's tough, because I still want my inputs to be -2 to 2 for the x. So how can I make it look the way I want it to look? Instead of doing the math backwards every time, let's change the equation. Let's make it easier. So let's solve for y. How do I do that? How do I get y by itself right now? Okay, so we'll start by subtracting 8. And now I've got negative y equals x minus 8. Is that okay? Should I leave it like that?
No,
Okay, so I'm going to divide it by a -1 because it's like a -1y. So I'm going to divide by a -1 on all of these. So it turns out to be y equals -1x plus 8. And this is the equation that I'm going to do. So the -1x comes from 1 divided by -1 is -1, and then -8 divided by -1, a negative divided by a negative makes a positive. So on a problem or two on your homework, you're first gonna have to switch the equation over to make it look like y equals. Now remember, I'm going to use my new equation that I just created. And even though it just says negative next to it, remember that's a negative times a negative plus a number. What's a -1 times a -2? 2 plus 8 is 10. Okay, go ahead and finish this one with your partner. This is the last one we're doing. At least compare the points with your partners.